Hi, everybody. Welcome to another Chats with Children. It's a beautiful sunny day here in Surrey. The sun is shining outside my window and it's a beautiful day, and it's made even better because today I'm joined by Alice Lee, who is the R&D project manager for MALDI Imaging at Bruker Daltonics. And you can guess what we're going to be talking about. Yes, we're going to be talking about MALDI Imaging today. So, Alice, how are you?
I'm great, thank you. I guess you're sounding great as well, but I have to say, how dare you rub in that it's sunny in Surrey because it's absolutely grey in northern Germany up here in Bremen.
I'm sorry to hear that, Alice. Well, hopefully my bright orange shirt and you talking to me will brighten your day up anyway. So let's see how it goes. All right. So we're going to be talking about MALDI imaging. But before we start talking about MALDI imaging and the challenges around that, perhaps for those people not familiar with Bruker, you could give them a quick overview of Bruker, your role within that, and how you got into MALDI imaging.
Yeah, so so I'm working for Bruker Daltonic, which is the mass spectrometry division of Bruker Corporation. I've been with Bruker for 5 years, based out of the mass spectrometry facility in Bremen. And as you said, I'm a research and development project manager specifically for MALDI imaging. I mean, when you think about mass spectrometry, you normally think about like chemistry or physics or analysis or so forth. But actually, so I'm actually a biologist. So I had studied biology with towards a pathology focus, so looking at changes that happen in tissue in diseases. And so, yeah, prior to actually joining Bruker, I was primarily looking at diseases of the eye, so diabetic retinopathy and retinal degeneration, but also in solid tissue cancers. So during my PhD in my studies, I had actually primarily used, of course, cell biology and like histology or microscopy-based techniques to look for changes in cell markers in different populations and so forth. So very classical techniques, very well established, but kind of limited in terms of throughput and multiplexing.
Right. Okay.
Yeah, so part of how I got into Bruker, who was of course especially their mass spectrometry division, was that actually as a postdoc, I joined a group that did eye research, so continuing on diseases, but they primarily used mass spectrometry. So they were actually an established mass spectrometry group. And part of the reason why I chose to join them and start learning this technique where I had absolutely no background was because I was attracted by the ability to really examine lots of targets simultaneously in my sample to basically, yeah, more quickly identify markers that occurred in different diseases, like what goes up, what goes down, the sensitivity of the technique. Yeah, and I mean, for people who do microscopy, you know, like if you look at a marker and you say, okay, this is up, this is down, and it's usually quite subjective. And I wanted something a little bit more quantitative, more objective than this. And so the thing was that when I joined this group and on the project that I was given as a postdoc, I actually became acquainted with MALDI imaging. So for those who don't know, it combines the multiplexing power of mass spectrometry with the classic spatial information that you get from microscopy. So if you can imagine, when I found out about this technique during my project, I was really blown away by the potential and the possibilities that this technique offered. Because, I mean, yeah, I was coming from an area where you target 2, 3, maybe 4 markers at the same time, like with antibodies and so forth on a tissue section. So then the possibility to look at hundreds, thousands, this was amazing. And of course, like Bruker is the leader in MALDI technology and MALDI imaging over the last year. So when the opportunity to join them came up, like I jumped at it. And so now that's how you end up with an Australian in Bruker.
Well, that's really interesting, and your enthusiasm about it shines through. So, for someone like me who's ignorant about all these things, what are the main applications that people would use MALDI for, and what are the main challenges that people face when they're using MALDI in terms of those applications?
Yeah, okay. So, of course, MALDI imaging is primarily used, or the largest body of work is probably tissue-based research. So not just humans, but also animal samples. So for example, if you've dosed an animal with drugs and you want to see this, but also in insect samples. But there's also a large body of non-tissue research as well, like people looking at plant metabolites or the distribution of things in particular samples that they've spotted on. And of course, then you can then look at the distribution of many molecules within your sample And by doing so, you can generate a molecular profile that you can use to kind of discriminate different structures in your sample, or also if you've got cohorts of tissue, and you can discriminate between your samples based on the molecular profile from the MALDI imaging. Also important to note is that, yeah, as I said, I come from a histology background. MALDI imaging is a label-free technique, and you can use this then to visualize the distribution of not just proteins and peptides, but also really well for the real benefit is to visualize compounds that can't easily be tagged with antibodies, for example. So, yeah, so glycans, endogenous metabolites. I already said drugs, so you can look for the mass of drugs within tissue samples. Lipids is also really good. Actually, yeah, so I know that you've done talks with like Lucy and Mike, and yeah, the imaging of lipids is really interesting because lipids, they have an essential role in cell biology and cell function. I mean, they're part of the cell membrane, for example. So changes in the lipid profile can be indicative of like just changes in biology, metabolism, the immune state. And the imaging of lipids is basically almost impossible with standard imaging techniques. Like it can say that there's a change maybe, but it won't tell you what has changed and how. And MALDI imaging can help you on that.
Okay. And in terms of, from a researcher's point of view, what are the main challenges when you're using MALDI?
Yeah, so the challenges that people can find with MALDI imaging is that, I mean, if you compare it, for example, to a liquid-based mass spectrometry, it is less sensitive. I mean, so the output doesn't give you as much as you can if you're doing in solution. But actually, that's not necessarily a negative. So as I said, I know you've spoken with Lucy and Mike before, and they've discussed spatialomics with you. So yeah, as I said, liquid mass spectrometry is sensitive, but you lose the specificity of knowing where your markers in your sample came from on a spatial level. So, I mean, take cancer, for example. When you have a cancer sample, I mean, it's not just cancer. There can also be blood vessels in there, inflammation, dying tissue and stuff. And if you all like homogenize it and put it into the machine, it can dilute compounds that you know might be in the tumor or in the connective tissue, or it can basically say something is increased, but it's hugely located to one area of the tissue and not the other. And so you're looking at the wrong compound or potential marker for your tumor. So in spatial omics, MALDI imaging is an integral part, because then you use MALDI imaging to kind of identify and define regions of interest that you say, this is actually really interesting, and I need to use this part to do a deeper, more complex analysis in solution to understand what's going on there. Yeah.
Brilliant. Okay.
So that's how MALDI imaging can compare to liquid imaging. But on a personal level, I know that some people, newbies to the field, might have this challenge that for people for MALDI imaging, there's a perception that it's a difficult fiddly technique because you're dealing with tissue samples, and also that it's the kind of the domain of mass spectrometry specialists. And this can also be a mental challenge mindset to overcome.
All right. Well, then how do you overcome that though? Then, so how do you overcome that? Yeah,
so we're overcoming this, of course, like with the developments that Bruker are having on to progress MALDI imaging for the field. So, I mean, as I said, I'm not a chemist. I still don't consider myself a mass spectrometry expert, but that's something else. I'm talking about myself a lot. But the idea is that we're looking to make MALDI imaging more accessible to all people. So having it not just a mass spectrometry tool, but to everybody who does tissue-based research. So we are working primarily on looking at ways to developments that have the overall aim of simplifying the entire workflow from sample preparation all the way to data analysis and everything in between. And in my role, I've been primarily looking, therefore, at software and consumables. Yeah. So I keep talking about myself, but when I first started MALDI imaging, I had this experience where different people would tell me, I was like, oh, MALDI imaging is really difficult. Like, you know, are you sure you want to do this? But eventually I kind of realized that MALDI imaging is perceived that way because it is a combination of two different technologies that normally don't have one person doing both sides.
Right.
Yeah. So you get people who would know how to use the MALDI mass spectrometer, but historically, because they never had to like cut tissue or so forth, they didn't know how to handle the samples for the mass spec, and they would depend on others to do that for them. But of course, those people, I mean, if they're used to using microscopy, they weren't fully aware of what they needed to be aware of to prepare a sample for mass spec, right? And so then, of course, I came along and I knew how to handle histology equipment, but I will admit to being a bit afraid of using the mass spec. You know, am I using it incorrectly? Is the instrument working? How can I tell? Things like this, because I wasn't aware of it. Yeah, so in terms of that, of making things more simple for users overall, so last year, Bruker launched IntelliSlides, and this helped users a lot because, I mean, when you have the slides, you can look very quickly on it and know where you're supposed to place the section, how you're supposed to place it on there on a mass spectrometry multi-compatible target. Right. And this allowed users also to automatically align their sample with the instrument's optics within minutes to micrometer accuracy. So these slides really hugely simplified an essential but very fiddly step to setting up an experiment.
Right.
And yeah, so, I mean, and then expanding on the theme of automation in multi-imaging experiment setup, we've now been working on a we're calling it the ease of use workflow to make data acquisition much easier. So in addition to having the automatic sample alignment that I said before we've used with the IntelliSlides, we've now also introduced automatic detection of your tissue sections on the slide itself. So you have a scan and the slide is aligned, and then an algorithm reads saying, okay, here's a tissue section, that must be a measurement region. And we've got different specialized algorithms for different kinds of tissue samples you might have.
Right, and that's based on the software that you develop?
That's software, yeah. And also in the software, people can now use also the IntelliSlides to check the performance of their instrument. So of course, we have different tools for checking and assigning specific things to know if your instrument is working properly. So like the correct detector voltage you should use, like laser focus, adjustment, calibration of the mass spec methods. And now with the IntelliSlides and our software, these tools are automated in the sequence that they should be performed. So you can just say, okay, I will perform these, and they're run through automatically. You don't have to sit there and say, okay, I have to do this and it needs this output, and is this right or wrong? So because the output can now tell you if the instrument is working correctly, so you can of course start your measurement. But the output can also tell you if something is wrong and what you should do about it. So right. This I think is a real benefit.
Okay, and that software, that's built into the machines, or is that additional software that you have to purchase, or how, you know, is that built in?
So this is, I mean, you have the mass spectrometer and you have the MALDI instrument, and you have the software that runs the MALDI instrument that controls it. And we have a special software called Flex Imaging that is used for the image acquisition. And this is in Flex Imaging, the 6.0.
Fantastic. And looking ahead, obviously working in R&D, you would have a better idea than a lot of people. Where do you see future developments around MALDI imaging? I mean, where do you think the next step is? I mean, you talked about simplification and making it easier for users and so on. So, but where do you see developments within MALDI imaging?
Yeah, so developments in MALDI imaging. So we kind of, as I said, like we'd like to kind of target this towards people like this technique should not be the domain of people who are mass spectrometry experts. So, I mean, for people with a similar background to myself, I would really love people to consider this as a technique that's a general one rather than a specialized one subset. So, I mean, if you think about things like microscopy or transcriptomics or doing PCRs, I mean, you don't have to know how a microscope works or a sequencing instrument works in order to do them. You can just say, okay, I use my machine, I prepare my sample like this, let's get it running. But also, I mean, I see that the multi-imaging now as a field, it's now 2 decades old. So there are people who've been there from the beginning, there are people who have come along as it's developed. And so overall, we've got an idea of how it works and how to make it work. And so, of course, there will always be labs that work on the development and companies like Bruker that work on development and improving technologies. But there will be some groups who say, you know, we've established this now, and we actually, we want to use our things more routinely because we're interested in using the technique to investigate different samples, not to tweak our machines all the time. Yeah, so as it is, like, you know, of course, we Bruker work with people in the multi-imaging field, like they give us feedback on what they like, how they want to use the instrument, what they don't like, and so forth. And we work together we've listened, we developed with them on how to make things new, easier for them, and also newcomers overall.
Brilliant.
Yeah.
Fantastic.
So,
That's a great overview of MALDI, actually. So thank you for that. And as I said, your enthusiasm shining through for the technique, so that's always good. So looking ahead, though, I mean, if people want to know more about MALDI and the solutions that you've been talking about, where can they get more information?
Yeah, so of course, like contact Bruker, contact your local your application scientist, your local salesperson, and also on the Bruker website. So www.bruker.com.
And type in MALDI most probably. So that'd be good. All right. Well, thank
MALDI.
you very much. Well, that's very, very good. So thank you very much for that. That's
No
been
worries.
really interesting. As I say, every time I do these, I learn something new every time. Being a non-scientist, I'm always learning new stuff when I do these interviews. So thank you for sharing your knowledge with me. So there you go, everybody. I hope you found that useful and you learned something new about MALDI imaging. If you'd like to know more, then as Alice quite rightly said, check out the Bruker website. You can type in MALDI in the search box and you'll get lots of on-demand webinars, posters, you name it, white papers. There'll be lots of information there around MALDI. If you've got any questions specifically for Alice, then please feel free to put a comment below the video, and I'm sure Alice will be happy to answer them for you as well, or message you directly. And all that stuff for me to say is, Alice, thank you very much. I hope the sun does start shining for you this afternoon in Bremer.
I hope so too. Thank you very much for your time, Rizwan. It's great talking to you.
Thank you very much. It's lovely to meet you. And thank you, everybody, for watching. As always, until next time, stay well and stay safe. Bye-bye.
Bye-bye.